Chapter 5.4 SSS Triangle Congruence. The SSS stands for side, side, side. En este capítulo, la SSS significa lado, lado, lado. Alright, so the last couple classes we've gone over the ASA triangle congruence theorem, which was angle, side, angle. We also did the SAS triangle congruence theorem, which is side, angle, side. Today we're going to do side, side, side triangle congruence theorem, or SSS triangle congruence theorem. This is very easy. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. In other words, if all three sides of one triangle are equal to all three sides of the other triangle, then the two triangles are congruent. All right, let's look at our first example here. All right, if you look at this example, we got a side that's 1.7, the other side is 2.3, and the other one is 2.4. So all three sides are equal. Therefore, if all three sides are equal, then the triangles are congruent by the side, side, side triangle congruence theorem, or SSS for short. All right, that's super easy. All right, let me just repeat that in Spanish. Or actually, before I repeat it in Spanish, let me tell you what's the main thing to look out for that on tests and on exams you may get confused by. We have a side, side, side triangle congruence theorem, but you know what does not exist? Angle, angle, angle. That does not exist. I'll repeat this in future classes, and before the exam, I'll go over that again. But that's the most likely thing that on an exam they try to confuse you with. There's no such thing as angle, angle, angle. Because you could have two triangles that have the same measure of their angles. Let me just say this is 90, 30, and 60, whatever. But they could be different sizes. One could be, bigger than the other one or smaller than the other one. So angle, angle, angle does not exist. Only side, side, side. Let me repeat all this in Spanish. Ok, en las dos clases anteriores ya aprendimos el teorema de ángulo, lado, ángulo y lado, ángulo, lado. Hoy el que estamos estudiando es lado, lado, lado. SSS o en español LLL, lado, lado, lado. Okay, este teorema dice que si los tres lados de un triángulo son congruentes a los tres lados de otro triángulo, entonces los dos triángulos son congruentes. Eso quiere decir que también los ángulos van a ser congruentes, aunque no se sepa la medida de los ángulos. Todo va a ser congruente. Con saber que los tres lados son congruentes, ya eso es suficiente. Y eso es lo que está pasando en este diagrama. Okay? Los dos triángulos los lados tienen el mismo medido, 1.7, 2.3 y 2.4. Así que con eso, y sin saber la medida de los ángulos, ya con eso se sabe que los dos triángulos son congruentes. Y lo que estaba explicando aquí es, tienen que tener cuidado. Sí existe un teorema de lado, 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 pero no existe un teorema de ángulo, ángulo, ángulo. Si los tres ángulos miden igual, eso no quiere decir que los dos triángulos van a ser congruentes, porque pueden tener la misma medida de los ángulos, pero los tamaños pueden ser diferentes. Un triángulo puede ser más grande que el otro. Así que siempre tienen que tener cuidado con eso. No lo van a ver hoy, pero sí sale en los exámenes. Te tratan de engañar con eso y eso no existe. One thing I forgot to mention, I said it in Spanish but forgot to mention in English, is that with the SSS triangle congruence theorem, even if we don't know the measures of the angles, okay, once we know that all three sides are congruent in both triangles, that means that all three angles are also going to be congruent, even if we don't know what their measure is. All right, let's go to our next example. All right, so right here, this is very easy. If you look at the three sides of this triangle and compare it to this triangle, you'll see that all three have the same side lengths, 12, 20, and 24, 12, 20, and 24. So they're congruent by SSS. Now let me just go by filling in the blanks because you're going to have this on your homework. So side DE DE is the 20 side, so that one is corresponds to the FG, because they both equal 20 centimeters, so I'm assuming they want me to write this here. DE is congruent to segment FG, or side FG. DH is this side, which is 12, so that one's congruent to FH. So segment DH is congruent to segment FH. Let me say this one in Spanish. EH, el lado que mide 24 y es congruente a GH, que también es el lado que mide 24 en el otro triángulo. Así que segmento EH es congruente a segmento GH. The three sides of triangle DEH are congruent to the three sides of triangle. Here you got to make sure to put the order of the letters correctly. DEH is going the 20 side first and then the 24 side. All right, so on the other triangle, it would be FGH. Okay, tienen que tener cuidado de poner la orden de las letras de los triángulos en la orden correcta. Así que el triángulo DEH está yendo primero el lado de 20 centímetros y después el lado de 24 centímetros. Así que en el otro triángulo sería el lado FG primero y después GH. Así que FGH para seguir el mismo patrón en el otro triángulo. So the two triangles are congruent by the SSS triangle congruence theorem. Los dos triángulos son congruentes por el teorema de lado, lado, lado. All right, let's go move on. Okay. All right, so here you just got to check, are they congruent by SSS? Yes or no? Tenemos que determinar si son congruentes por lado, 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 sí o no. So the first one, 54, 28, 38, nope. This one right here, look. This side has, let me write that better. All right, this side has this one line, so this side equals this side. Este lado es congruente a este lado. Eso es lo que significa la rayita. This one has two lines, so it equals this side. Esta tiene dos rayitas, así que es congruente a este lado. And look, the side that they both share, the side that they both have in common, they both have it equal as well. All right? El lado que los dos triángulos tienen en común, tiene que ser igual para los dos triángulos. Así que sí, son congruentes por lado, lado, lado. Yes, they're congruent because of SSS. All right? Someone who's not paying attention might read that. Yes. All right, that was a corny joke. I'll move on. Okay, you know what? I didn't go into all these details. I don't think it's really that necessary. As long as you see that they're congruent because of SSS, that's the important part, okay? Same thing, same type of question here, okay? Are they congruent, yes or no, by SSS? Okay, esto es el mismo tipo de pregunta. Quiero que puedan mirar y determinar si son congruentes por lado, 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 sí o no. All right, so number 10 is easy. 6. By the way, obviously I'm comparing the two triangles. Estoy comparando los dos triángulos. All right, the 9 side goes with this one, and the side that they share in common, el lado que tienen en común. So yes, because of SSS. All right, number 11. Okay, no, number 11 cannot be, well, yeah, they cannot be correct because, okay, this side has one line, so it equals this side. This side has two lines, so it equals this side. However, I'm going to bring up something from a couple of classes ago, or from the previous class. SAS, the angles here are not equal. So therefore, they are not congruent. Okay, because look, notice that SAS does not work. Side angle side does not work because the angle in between is not equal. Okay, so this is going to be no. Also, it doesn't tell us what the other side, it does not tell us what the third side measures. So no, they're not congruent, okay? Dos cosas. En este ejemplo, okay, si uso el teorema de la clase anterior, lado, ángulo, lado, uno puede ver que los ángulos estos no son igual, no son congruentes. Así que no puedo determinar que son congruentes por lado, ángulo, lado, porque este ángulo no mide igual que este ángulo. Y también no nos dicen cuánto mide el ángulo que falta. ¿Ok? Perdón, el lado que falta. Así que por eso no puedo determinar que son congruentes. Así que no. Ok. Number 12. There's not enough information to determine that they're congruent. So no. No hay suficiente información para determinar si son congruentes. Así que no. I don't know how much this side is. So that's why I cannot determine if by side they're congruent. And number 13, same thing, okay? The same thing. This side does not equal this side does not equal this side. No. Okay, 13, los lados no miden igual, así que no puede ser. All right, by the way, notice what they put for number 12, because I'm pretty sure there's on your homework assignment, there's a question that I'm pretty sure has that answer. All right. The answer they didn't put not congruent, they put possibly congruent, depending on the lengths of the unlabeled sides. That's on your homework. All right. So make sure you realize that. Why? Because we don't know what the third side in each one measures, so it might be congruent. We can't tell for sure. Okay, en número 12, hay una pregunta como el número 12 en la tarea. Fíjense que la respuesta dice posiblemente congruente. Depende del largo de los lados que no están marcados, que los lados que no se sabe cuánto miden. Así que es posiblemente congruente. All right, let's go to the next slide. Okay, now we're using algebra here. It says we've done problems like this in the last couple of classes, all right? It says find the value of x for which you could show the triangles are congruent. In other words, what does x have to be in order for both of these triangles to be congruent? Well, the only information that they're giving us in both triangles is the length of the side, and the side. The side, and the side. So these two sides obviously equal these two sides. So the only way these two triangles can be congruent is by the SSS triangle congruence theorem. Okay? The only way they could be congruent is if this side equals this side. And that's how I'm going to do my equation in order to solve for x. I'm going to make 4x minus 6 equal to 3x minus 4. Let me say that in Spanish real quick. Okay, la pregunta es, encuentren el valor de x para cual se puede enseñar que los dos triángulos son congruentes. Ok, solamente nos dieron información para los tres lados en cada triángulo. Este lado y este lado son congruentes a este lado y este lado. Así que lo que falta para que los dos triángulos sean congruentes es que este lado mide igual que este lado. Ok, así que así voy a escribir mi ecuación. 4x más 6 tiene que ser igual a 3x más 4. 3x menos 4 para que los dos triángulos sean congruentes. Ahora, ¿qué valor tiene que tener x para que estos dos lados sean equivalentes? Ok, así que voy a mover 3x para la izquierda. Move 3x to the left by subtracting. Alright, that way this will cancel out and 4x minus 3x is x. Y voy a mover el 6 para la derecha sumándolo. I'm going to move the minus 6 to the right by adding, by doing the opposite of minus 6. Estoy haciendo lo opuesto de restar 6. Negative 4 plus 6 is positive 2. That's it, that's my answer. Alright, let's look at another example like that one. Aquí hay otro problema como ese. This is the same exact thing. So this side, in order for this triangle to be congruent to this triangle, this side has to equal 4. Para que este triángulo sea congruente a este triángulo por lado, este lado tiene que medir igual que este lado, que dice que es 4. Alright, so that's how I'm going to set up my equation. 3x minus 11 has to equal 4. All right, basic algebra. Move the minus 11 to the right by doing the opposite of subtracting 11, which is adding 11. And you're going to get 3x equals 15. Now divide both sides by 3. Ahora dividen los dos lados por 3. So x is going to equal 5. Now let me fill in the blanks here. Notice that segment PQ is congruent to segment MN. PQ, where's PQ? Right here. PQ is congruent to segment MN. And what segment is congruent to MO? That would be PR. Because they have the same measure. If segment NO is congruent to segment QR, then triangle MNO, follow that same pattern. By the way, it's in alphabetical order also. Has to be congruent to MNO, PQR, if I'm not mistaken. PQ. Yeah, PQR. Estoy siguiendo la orden alfabético. By the side triangle congruence theorem. Por lado. Write an equation setting the lengths equal and solve for x, which is what I did first. All right, let's go to the next example. All right, this is almost the same thing, but it's like two problems in one. And there's one or two like this on your homework, so please pay attention. Esto es básicamente la misma cosa, pero son dos problemas en uno. Y esto está en la tarea, así que pongan atención, por favor. All right, Craig made a mobile using geometric shapes, including triangles shaped as shown. Whatever. For what values of x and y can you use a triangle congruence theorem to show, that's the important part that I'm underlining, to show that the triangles are congruent? Okay, la parte importante es lo que está aquí. Okay, ¿para cuál valores de x, y existen o pueden usar una teorema de congruencia de triángulos para enseñar que los dos triángulos son congruentes? All right, so look, let's point out a couple things here. Which should I start with? All right, let's start with the angles. Let's look at the angles first, all right? So this triangle right here, this is 90 degrees, and this is 60 degrees, all right? So the angle, by the triangle sum theorem, which says that when you add up all the angles of a triangle, it always equals 180, that means that this one has to be 30 degrees, because if this is 90 and this is 60, the remaining one has to be 30 for all of them, for all three of them to add up to 180. Let me say that in Spanish. Okay, este ángulo aquí es 90 grados y este ángulo es 60 grados. Como ya se sabe que la suma de los tres ángulos de un triángulo siempre te tiene que dar 180 grados, entonces si esta es 90 y esta es 60, la que falta tiene que ser 30. Okay, so look at the other triangle. All right, in the other triangle it says that this one's 90 degrees, this angle is 30 degrees. Again, by the same theorem, that means this one has to be 60. And look what they wrote there, 7y plus 4. All right, so to solve for y, I gotta solve this equation. 7y plus 4 equals 60 degrees, okay? En este triángulo, el ángulo que falta tiene que medir 60 grados para que la suma te dé 180. Y lo que escribieron ahí es 7y más 4. Así que con esta ecuación puedo resolver para y. All right, so 7y plus 4 equals 60. I move the plus 4 to the right by subtracting 4. All right, so that's going to give you 56 equals 7y. Now to solve for y, divide both sides by 7. This cancels out, so y equals 8. All right, y equals 8. Okay, now let me erase all that. Y equals 8. Y equals 8. Oh, and by the way, I forgot to write something. It says which triangle congruence theorem can you use? I forgot to write. So for y equals 8, the triangle congruence theorem that I used is the triangle. You know what? Wait, my bad. Hold on. You know what? No, that's wrong. What I was going to write. That answer is right, but I'll get to the second part of the question in 1 second. Hold on 1 second. All right, so now we got to solve for x. All right, now we got to solve for x. Okay, now notice that this side goes with this side. Okay, and we already figured out that this angle right here is 30 degrees. Okay, we already figured out that this angle right here is 30 degrees. Okay, so listen, I'm going to solve this. Look, this angle is 90. Sorry, guys, I'm thinking and I'm pausing while I think. All right, look, this angle is 90. Here's the side that we're dealing with, and this angle is 30. Notice that on the other triangle, it's the same thing. This angle is 90. Here's the side that I'm dealing with, and this angle is 30 degrees. Okay, so what I'm using like for this one is the angle, side, angle theorem. Angle, side, angle. If two angles and the included side equal two angles and the included side of another triangle, then the two triangles are congruent. So 8x minus 12, I'm going to make it equal to 12 and solve for this triangle. Wow, this one has weird numbers because we're now, oh, never mind. Forget I said that. All right, I'm going to add 12 over here and I'm going to get 24 equals 8x. Now divide both sides by 8 and x equals 3. I kind of paused because now I'm realizing that I think it would have been helpful to do this one first and do the y second. But to be honest, when I first read the problem, I didn't realize at first how to get the x. So I was like, let me do the y first, and then it'll hit me how to do the x. All right, but that's how you get the x. And I'll let me say it in Spanish, and I'll come back and rewind from the beginning. All right. En español. Ok, fíjense que este ángulo es 90 grados. Aquí tenemos el lado que tenemos que resolver para x y este ángulo mide 30 grados. Así que ángulo, lado, ángulo. Y en el otro triángulo tengo el ángulo que mide 90 grados, este lado y este ángulo que mide 30 grados, igualito que en el otro triángulo. Así que ya aprendimos un teorema de ángulo, lado, ángulo. Ángulo, lado, ángulo. Que si en dos triángulos uno ve que tienen el ángulo, el lado incluido y el otro ángulo congruente a el ángulo, el lado incluido y el otro ángulo de otro triángulo, entonces con esa información los dos triángulos tienen que ser congruentes. Así que por eso hice 8x menos 12 es igual a este lado que mide 12. Porque si esos dos lados son congruentes, entonces por ángulo, lado, ángulo, los dos triángulos tienen que ser congruentes. Así que resolví para x y la respuesta para x es 3. Pero estaba diciendo que ahora me di cuenta que creo que hubiera sido más lógico resolver para x primero y después para y. Pero cuando vi el problema, lo primero que pensé es cómo resolver para y y no pude pensar hasta ahora cómo hacer para x. Ok, así que déjame explicarlo de nuevo desde el principio, bien rápido. All right, quick recap then. All right, so I see this problem. I should have done the x first, I think. You could do it either way, but anyways, why should I? It says explain which triangle congruence theorem can you use, all right? So because the first thing I should have done is realize that, oh, this is 30 degrees right here. Okay, and if this is 30 degrees and this is 90 degrees, that means that this side right here has to equal this side right here because of ASA, angle side angle. Because this one's 90, here's the included side, and 30. This one's 90, here's the included side, and 30. So by ASA, I could have solved that x equals 3, right? That's the first part of the answer, okay? Cuando empecé el problema, lo primero que me di cuenta es que este ángulo mide 30. Así que, porque este es 90 grados, tengo que resolver para este lado y este ángulo es 30 grados. Eso es igual que en este triángulo donde tengo este ángulo de 90 grados, el lado incluido y este ángulo que mide 30 grados. Si puedo enseñar que este lado mide igual que este lado, entonces por angle side angle, ángulo, lado, ángulo, la teorema de ángulo, lado, ángulo, puedo determinar que los dos triángulos van a ser congruentes si encuentro el valor para x para cual este lado, puedo enseñar que este lado mide igual que este lado. All right, and then for the y, let me think for y, the answer was, let me first remember what the answer was because I erased it. It was... Hold on, I did 7y plus 4 equals 60. I subtract, so... Alright, so it was 8. The answer for y was 8. And for the theorem... hold on, why is this one? So... It's got to be either ASA, SAS, or SSS. Maybe they did put triangle sum theorem. Let me see what the answer is, because I honestly can't remember. Alright, this is what I was going to write at first. No, wait, hold on. So, oh, my bad. They just used this theorem for both, because I was stuck on what to write for which triangle congruence theorem can you use. Alright, so they just wrote for both of them that the triangle congruence theorem you're using is ASA. Ok, escribieron para las dos, para X y para Y, que el teorema que se puede usar es ASA. Alright, sorry, I didn't mean to make that one. I made that one a little confusing, my bad. Alright, hopefully you understood, everybody. Remember, you could always rewatch the video and pause it. Alright, is that it? Oh no, I have let's look at this one. Alright, so I believe there's a question like this on your homework, right? So we already did questions like this, right? Basically the same thing we just did, right? What value must x have in order for both of these triangles to be congruent? And what theorem, what triangle congruence theorem are you using? Let me answer that second question first. It's got to be side, 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 because that's the only information we have. So it's got to be using side, 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 and this side would have to equal this side. All right, so just put them equal to each other and solve for x. And while I solve it, I'll explain it in Spanish. Okay, esto es lo mismo que acabamos de hacer. ¿Para cuál valor de x? Bueno, primero que nada, ¿cuál teorema se puede usar para que estos dos triángulos sean congruentes? Como solamente nos dieron las medidas de los lados, tiene que ser lado, lado, lado. ¿Ok? Y para que sea lado, 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 este lado tiene que medir igual a este lado. Por eso es que hice mi ecuación de esta forma. Ahora estoy resolviendo para x. Alright, so if you know your timetables, you already know the answer. Divide both sides by 9. So x equals 4. Alright, Alright, now this one, same thing. La misma cosa. Which triangle congruence theorem can you use? Alright, based on the information, on the only information they gave us, it's got to be ASA. Angle, side, angle. Angle, side, angle. Ok, mismo tipo de problema. ¿Qué teorema se puede usar? Tiene que ser ángulo, lado, ángulo. Ángulo, lado, ángulo. Porque eso es lo único que nos dieron. Alright, so this side has to equal this side. Let me do that one first. Alright, to solve for x. So I move the 47 to the right by adding. That's going to give me 56. Now I gotta divide 56 by 14. For all you guys that are bad at dividing, I don't have my 14 timetables memorized. However, what I could do is just look at what number do I multiply by 4 to get a number that ends in 6. Is it 2? No, 2 times 4 is 8. Is it 3? 3 times 4 is 12. Is it 4? Yeah, that's it, because 4 times 4 is 16. It's 4, because 4 times 4 is 16, so you put a 6. And you carry the 1 over here. 4 times 1 is 4, plus the 1 that you carried is 5 for 56. All right, so the answer is x equals 4. Now let's solve for y. Okay, by the triangle sum theorem, if this angle is 30 and this angle is 60, this one has to be 90 so that they'll all add up to 180. Same thing here. If this one's 30 and actually, hold on. By ASA, just like the last one, by ASA, that means these two triangles are congruent. So that would make this angle 90 degrees, all right? Por ángulo, lado, ángulo, estos dos triángulos tienen que ser congruentes, así que este ángulo tiene que medir igual que este ángulo, que es 90. And that means that this angle has to equal this angle. Este ángulo tiene que ser igual a este ángulo. So I set up my equation. Same little trick I did over here. This one you should memorize because it comes up a lot. 60 divided by 15 is 4. Everybody should know that 15 times 2 is 30. And 30 times 2 is 60. So 15 times 4 has to be 60. Alright, that's it, guys. The homework assignment is in the student portal. And like always, it's due by 6 a.m. of the next day that you have my class. Remember, you could do it up to 10 times if you get a bad grade. Ok, la tarea está en el portal de estudiantes. Recuerden que lo pueden hacer hasta 10 veces para coger el mejor grado posible y lo tienen que entregar antes de las 6 de la mañana el próximo día que tienen mi clase.